Right now, we're going to be working on 2.7. And that, to begin, I'd like you to consider the stuff that I wrote on the board. I'm not sure if you'll be able to see this, but let me read it at least. So here's a scenario. Let's pretend I was doing some kind of research and I start showing off saying, hey, when I sell more tickets to Wonderland, the weather gets warmer. Take a look at my data. Look, look, look. As I make more money, the temperature is going up. Amazing. What's wrong with that statement? Think about it. I make more money and the temperature gets warmer. Go ahead, Aya. What do you mean by reversed? So right now, what we would call, if this was data management or something along those lines, I believe we call this a reverse cause and effect. Okay. So in science, we always have the independent variable, if you remember, on the x-axis, and then the dependent variable on the y-axis. So this controls this. Like if this was chemistry, you might have time here, right? And as time passes, I don't know, maybe you were trying to measure the temperature of the reaction. As time passes, the temperature changes, right? That could be a realistic relationship. Or let's talk about finances. As time passes, the money that you make goes up when you're at a job or something. Or as time passes, something. So this is what controls that. So if I write it this way, it is under the assumption that my money controls the weather. That's not right. That's not true. That's a big lie. Right. Well, you know what? That's very interesting that you mentioned that. It's because mathematically, it is trying to prove rationality, right? So when you say, I thought it was just rational, yeah, you're right. Now let's use numbers to prove that you're correct, right? It's the same world. So again, so what's wrong with the statement and how can we fix it visually? And Dahlia's like, well, we gotta switch it. Well, if we're gonna switch it, how do we do that mathematically? As I said, there are situations in this world, particularly in science, where we're trying to discover new relationships between two things. Like some of the things are obvious, like I put in more medicine, bacteria die. But what if it wasn't something as similar? What if it was if you spend more, no, if the amount of ketones in your body increases, the amount of fat on your body decreases. How do you know it's reverse? How do you know that it's because of the ketones you lose weight? What if because you lost weight, there's more ketones released in your body? Right? We don't know what the actual cause, we don't know what's controlling what. And so if there is a need to switch the cause and the effect because we got it wrong the first time, right? There must be a way we can do it mathematically. If there's a need for it in the outside world, we need to be able to do it in this classroom. Yeah? Yes. Realistically speaking, if the temperature got way too hot, people will stay in because they probably have heat stroke and get sick at Wonderland, which happens, unfortunately. Okay. So this is 2.7. And we call the idea of switching inverse, not universe, like inverse. And I'm going to show you how that is mathematically, what that looks like graphically, and what are some tips you can use to make sure that you're on the right track. And then we're done. We'll do some practice questions together and then take our break. Okay. Any concerns before we start? So I'll say it one more time. If there is a need for it in the outside world, if there is a use or if there is some kind of application to it in the outside world, we need to be able to prove it, or we need to be able to execute it using numbers so that math can help that world. Okay? I can see the dot. Thanks, Alex. Let's share screen. I am going to share my document, which did I download yet? Course classroom.google.com. I want my TDSB and posted. Download this. I'll just open that and I will. Nice. You know what? I'll just annotate it here. Sharing. All right. So this is my sheet. I'm hoping people got a chance to do it. And again, I'm just going to read it. Recall that a function is a rule that associates one x with one y. But there are times where we mix up the x's and y's. When we say, oh, this is x controls the y, what if it's the other way around? And we have to change the y into the x. That's literally how simple it is. Introducing the inverse function. Sometimes the inverse of a function is also a function. And so we give it a special symbol. And I'll tell you what that is. And this is my explanation of what we just did. Why is this useful? Sometimes we accidentally have a reverse cause and effect relationship. So we need to exchange the x and y variables and then simplify. The symbol that you're going to be seeing to represent an inverse function, okay, is f of x, but with a little -1 as an exponent. It's not an exponent. It just looks like it's a superscript. So this is the inverse of the function, whatever it is that we're dealing with. And now we'll learn how to do it mathematically. Okay. Oh, I don't see the equations. Let me see. Do I have to download it after all? Oh, yeah. All right. Let me reshare my Word document instead. And here it is. Enable editing. Better. All right. So we've just stated that if we want to do the inverse, we need to exchange the x and the y's. We need to exchange the x and the y's. We need to exchange the x and the y's. Daniel, what do you think? We need to exchange the x and the y's. What do you think that means? So my first point is not 0, 6, but yeah, that's all it is. That's literally all it is. Okay. Dahlia was mentioning, yeah, you got to switch, you got to change the location of x and y. It's reversed. Yeah. So let's reverse it. X and y, you flip it. So it's 6, 0, 7, 1, 8, 2, and 9, 3. Okay. Is this a function? Yes. Then this is okay for me to keep this symbol right there. Okay. Just a notation. All right. Next, I want to show you graphically how an inverse might appear, and it will give you a sense of whether you're going in the right direction or not. So they give me my function of -2, 0, -1, 1, 0, 3, 2, 6. That means my f of inverse would be 0, -2, +1, -1, 3, 0, and 6, 2. Let's plot both the function and the inverse function. So my function is going to be in red, and then my inverse function I'll use with a different color. -2, 0. there. Negative 1, 1, right there. 0, 3, there. And 2, 6, right there. You're not supposed to connect the dots, but just for me to show you the what's happening to the function, I'm going to do it anyways. Okay, so it's going to look something like this. Normally, I wouldn't connect the dots because that doesn't make sense. Yes. No, you shouldn't. Yeah, because I specify only the points, right? Yeah. So let's do the inverse function. Inverse function is 0, negative 2, 1, negative 1, 3, 0, and 6, 2. I have to draw a line. What do you think? Is there a similarity between the two graphs that we were drawing? Sort of. Yep. It looks like a mirror image. Where is the mirror? Where is the mirror? Here. I know what you're trying to say, but oh, oops, I ran out of space. Here's my mirror. Right there. What's the identity of this line? Yes. The mirror is that. Graphically, an inverse function is basically whatever function you have is flipped with y equals x as the axis of reflection. You might have noticed by now, axis is just another word for a line. Okay, axis of symmetry, axis of reflection. I think I would probably do this as a dotted line if possible, just because it helps us see. So if you have a ruler, please, by all means, use it. What do you think? Everyone's okay so far? It's very straightforward. But then from here, I'm going to give you some equations. You can try graphing it. And let's see how we can actually calculate the inverse mathematically if you aren't given points but a function instead. So let's go to the back page. All right. Algebraically, determine the inverse of a function. I gave you a relatively simple one, but it's the first time, so it might look hard to you first. Step 1, take the f of x. I don't want to use function notation. I need the y value there so that I can switch it. So I'm going to actually change back into y. So I'm going to write y is equal to 3x plus 2. Okay, so I'll write a little thing. Replace f of x with y. Okay, and basically you're bringing it back to what we normally know. Step 2, you're literally going to swap locations of x and y only. You're literally just flipping it. Let me do it. Here, come here. You sure? Wow. It's taking a big risk. All right. Swap locations of x and y only. X equals 3y plus 2. You're literally taking the x and y and changing its location. But I don't want to leave it like this because we are used to having the y all alone. So your final step is rearrange to isolate for y. Get y all alone. Create me an equation of y equals something. So let's get 3y. That's the term. Let's pretend we want to get this all alone. Leave that, cover it with your finger. Let's get rid of the plus 2. How do you get rid of plus 2? Thank you. Minus 2 on both sides. Great. Now, 3y is now all alone. So now I want y all alone. Let's get rid of the multiplication of 3 by dividing by 3. Yeah. So you divide both sides by 3. Remember, the entire thing is divided by 3. Y is equal to x minus 2 over 3. You can also rewrite this as x being divided by 3 subtracted by 2 being divided by 3. Now, do just a very quick fraction manipulation. That means my slope is actually 1 over 3 as a multiplication. And my y-intercept is negative 2 over 3. Okay. So my inverse function as my final bit, replace the y with the inverse function because that's what it is equal to 1 over 3x plus 2 over 3. Another straight line. Let's draw it. I will use a red. F of x is a slope of 3 and my y-intercept is 2. So here's my 2. Rise, run. Rise, run, rise, run. And my rise of negative 3, negative 1, negative 3, negative 1, negative 3, negative 1. And I will connect it all with a arrow. Okay. So far, so good? Okay, questions? Now we're going to go about drawing the inverse function. You can do this two ways. If you want to reflect this on the y equals x line, you can. Or if you remember that this is, y equals mx plus b, we can do that. I'm going to start with negative 2 over 3 as my y-intercept, which is like right there. And I'm going to do a rise of 1, my run of 3. So it's rise, run. Rise, run. And it is annoying because I have to deal with thirds. Rise, run. And then negative rise, negative run. Negative rise, negative run. Take it slow. Take it slow and then see if you are getting the same answer as I am with this drawing. Take it slow. Remember, you're starting with negative 0.66666. So it's going to be annoying. Starting at negative 0.666, we're starting our slope of 1 over 3. How's it going? It's going. It's just really, really, really annoying. Yeah, just be careful of that. Just it's good practice to always to even try to be as exact as possible. So the dot isn't actually on the line because we're dealing with a fraction, but it's okay. It's okay. Is that everything's okay? So far, so good. All right, nice. Yeah. Yep. Uh-huh. Either one's okay. Either one's okay. Yeah. To me, they are one and the same. Okay. And again, if you want to check if you are on the right track, just draw your imaginary y equals x line and see if that seems to be a nice mirror. You don't want to draw it because your graph is too pretty. Get a ruler and stick it where it's supposed to be to see if that ruler serves as a mirroring butterfly line. Yes. Are you what? Maybe. I hope so. My 3.1, 3.2 is a little long, but it shouldn't be too bad. I hope so. Okay, so here. Okay, I'm not sure if it works because this is casting a shadow. I wish this place had a. Yeah, that works, right? So I know I'm doing it right. I'm on the right track. Okay. All right. So knowing that we're on the right track, we could see more complex functions being given to you. It's just a matter of you knowing how to swap the y and the x and then rearranging it to get y all alone. Take a look at my last example. I don't ask you to graph it. I'm going to ask you to just do the math behind it and then see if you can identify what the domain and range is without graphing. Okay, here we go. I am giving you a reciprocal function. Amazing. Let me pause the recording. Okay, that was a weird interruption. I am going to do the exact same thing as it before, following the steps of 1, get back the y value, 2, exchange x and y, 3, isolate the y. Okay, so my function is right now g of x, 2 over x plus 4. Step 2, if I want the inverse function, I am going to assume the two locations were swapped. Okay, so I need to swap where they are right now. Okay, the next part's a little funky, but I think you can do it. I need to isolate for y. The y is in the denominator. People don't like dealing with fractions, and that's understandable. If you don't like fractions, how about we get rid of the fraction? How do you get rid of a denominator? Remember, it's a division. No, we can't just subtract because it is a fraction. Remember, it's 2 divided by y plus 4. What's the opposite operation of division? So multiply both sides by y plus 4. Let me show all the steps here. X times y plus 4, give me a second, and 2 over y plus 4 times y plus 4. Yes. Uh-huh. Yes, I know exactly what you're saying, but I don't want you to memorize that. People have memorized it so much that when the function gets more complex, they make silly mistakes. I'll go so far as to say they make stupid mistakes. Let me show you why that's happening. I'm going to multiply both sides by y plus 4. This becomes 1, right? Leaving me with x, y plus 4 equals 2. Now that the fraction is gone, we can just, safely do normal, normal, I guess, algebra. If I want x plus 4 all alone, how do I get rid of this number multiplying with it? We divide. Divide both sides by x and take a look. Y plus 4 equals 2 over x. So this is why it's happening, but I don't want you to memorize it. Okay? If you memorize it, if this gets more complex, you might make a mistake. I mean, if you're confident, that's okay. Yeah, I'm just a little bit, afraid that you might do something you're not supposed to. Just sometimes it's easier, it's better to do, one step at a time. But again, as you build experience, I'm sure you'll be okay with just swapping it. Okay. Now that we have that, y is equal to 2 over x minus the 4. Take a look. A horizontal shift of 4 to the left became a vertical shift 4 down. Does that make sense? I think so, right? If you flip it, and what is it? A vertical stretch of 2 remains a vertical stretch of 2. What should it be? A vertical stretch of 2, when I flip it, should become a horizontal. No, it's still a stretch. Like if I'm stretching this way, The same thing, right? Horizontal stretch of 2. But what does a horizontal stretch of 2 look like? A horizontal stretch of 2 is, which if you simplify it, turns into this anyways. It's one and the same, right? So again, reciprocal functions, they do some funky stuff just because it's fractions. But anyways, here's my inverse function. Inverse of f of x, okay, is 2 over x minus 4. Looking at this, what do you think its domain and range might be? X is a little easier than R, I think, but I might be wrong. What do you think? What can't X be? Yep, the denominator. Good. Yeah, but what about the Y? I'll give you this one. This fraction is never 0, right? It could be a positive number or it could be a negative number, which means, will this ever be left alone? It's always going to be minus 4 plus something or minus 4 minus something. So the Y value will never be just negative 4 because that fraction will never equal a 0. So there it is. This is inverse function. Okay. I don't think I'll be presenting anything harder than a reciprocal function to calculate the inverse. I mean, reciprocal, as far as we know right now, at this point in grade 11, is the hardest or the most complex type of function that I can give, or the trickiest one. In case you forget, in summary of this entire lesson is here. And I think I assigned a bunch of inverse homework questions on the bottom of the sheet. What I'd like you to do after we come back, maybe you can attempt some of these on your own time before we leave today. If you want to cool your head, that's okay. It is now 10 o'clock. I would like to give you at least a 15-minute break. So let us reconvene at about 10:15, and I'll see how everyone is doing. Okay? Yes, yeah, do your thing.